Good morning, and welcome to the Black Mesa Transit System. This automated train is provided for the security and convenience of the Black Mesa Research Facility personnel.
I keep getting asked about AI security and how to secure agents, and we'll get into that in detail, but I can't stop thinking about the opening lines of the game Half-Life. It's pretty old now, and it's super relevant to everything we're seeing today. So we will go over the opening scene a bit. We'll do a incident post-mortem of the Resonance Cascade incident, and then we'll do a deep dive of basically AI security and how to secure agents. So in the beginning of Half-Life, you are Gordon Freeman, a scientist, and you're about to conduct an experiment. And here are some of the lines of the scientists around you. I've watched the first few seconds of this maybe 50 times. Every single word is just a goldmine of insight of like how real incidents happen.
I'm afraid we'll be deviating a bit from standard analysis procedures today, Gordon.
Deviating from standard analysis procedures. That's always a famous last word in incident.
Yes, but with good reason. This is a rare opportunity for us. This is the purest sample we've seen yet.
Our smartest model yet. There's always a reason for us to deviate from procedures. It's like, oh, we just want to test this new AI tool.
And, potentially, the most unstable.
Now, if you follow standard insertion procedures, everything will be fine.
I don't know how you can say that, although I will admit that the possibility of a resonance cascade scenario is extremely unlikely.
The person on the right is kind of like a security engineer trying to call out the risk in things as you should be.
Gordon doesn't need to hear all this. He's a highly trained professional.
I'm not.
We've assured the administrator that nothing will go wrong.
We've assured the administration that nothing will go wrong. Why would you say that? Why would you ever say anything like that? That's the example of a bad manager that just wants to please administration by just lying.
Yes, you're right. Gordon, we have complete confidence in you.
They shouldn't.
Well, go ahead. Let's let him in now.
Now you're in an isolated environment where the experiment happens.
Testing. Everything seems to be in order. Stage 2 emitters activating now.
Gordon, we cannot predict how long the system can operate at this level, nor how long the reading will take. Please, work as quickly as you can.
Overhead capacitors to 105%.
They put the capacitors to 105%, so they're overloading the system.
It's probably not a problem. Probably, but I'm showing a small discrepancy. Well, no, it's well within acceptable bounds again.
So he notices a small discrepancy. It's like seeing something in your logs and thinking like, this is definitely suspicious, but you know what? Never mind, it's probably fine.
I've just been informed that the sample is ready, Gordon. It should be coming up to you any moment now. Look to the delivery system for your specimen.
So this little robot is holding a crystal at the front, and that's a crystal from the planet Zen. That's what's gonna cause the incident, basically. It's an anomalous crystal that we shouldn't be trusting anyway. Attempting shutdown. It's not working. This is you, the security engineer, laying completely dead on the ground in a pool of your own blood. How did that happen and why? We're gonna figure that out. Post-mortem of the Resonance Cascade incident. First, let's note the stakeholders. So the scientist that was on the right was our security engineer, and he was trying to warn us of the risks. But left scientist was a bad security manager because he was trying to make false promises to leadership that we promised them that nothing will go wrong. Why would you do that? Now, an interesting thing is in the Half-Life story, the government sends in Marines.
I've killed 12 dumbass scientists, and not one of them's fought back.
They first send a bunch of Marines, then they send Black Ops after them. Basically, they tell them, just kill everyone at the Black Mesa research facility because there's aliens, but also we don't trust the scientists there and we want to cover everything up. And then eventually at the end, they just nuke the whole Black Mesa research facility. And that is bad leadership who are trying to cover things up or just banning everything. Like if you just ban tools completely, people will just get around them anyway. If you try to cover up incidents, also just never gonna end well for you. And then you have G-Man.
Gordon Freeman in the flesh. Or rather, in the hazard suit. I took the liberty of relieving you of your weapons. Most of them were government property. As for the suit, I think you've earned it.
Mike Shapiro is the best voice actor. Every time I hear those lines, I get goosebumps. Now, G-Man, complex character, my favorite supervillain of any franchise ever. If he is the villain, I guess he is. He kind of has an incentive to cause the misalignment we've seen. Who has an incentive to cause misalignment? Spreading fear. I see him as the CEO of model providers. That's your Sam Altman or Dario. Psychotic figures that want to cause chaos and always pretend that their own models are going to end the world. Now, what infrastructure do we have here? First, we have Black Mesa Research Facility itself, and that's like the whole research center that we enter through a train first. That's your perimeter, and we'll see why I'm mentioning that in a bit. Then you have Sector C. Sector C is essentially like the section of the research facility where we're conducting this experiment. So Sector C testing labs is basically your endpoint of like where the testing is happening. Then you specifically have lab C33-A, and that is the room in which the experiment is being conducted. We're going to consider that the sandbox. We'll see why. Then you have the Zen crystal sample GG 3883. That's the yellow crystal we saw. And I consider that to be the model. Now you could say it's like an untrusted entity that we're processing. But for the analogy here, it's going to be the model that we're using. And Gordon Freeman himself, you might think like, why did I not list him under stakeholders? That's because I see Gordon Freeman as the AI agent itself. He was basically given instructions to operate within a sandbox, and those instructions essentially ended up causing a sandbox escape or a jailbreak. Now let's talk about the timeline. At the beginning, we have a deviation from standard operating procedures. Then there was confidence in the agent, no extra guidelines. They just trusted he's going to know what to do. They overloaded the system. 105% was mentioned. Then there was discrepancy in monitoring and no action taken. A very important one is a failed attempt to shut down. So we hear him saying like trying to shut down, then and then they die, right? And so that was a failed mechanism in itself. And eventually that caused the sandbox escape or, blow up. Something bad happened, right? And so what are some of the findings that we have because of this timeline? So the first thing is there was actually a policy exception here, and they know they were deviating from standard operating procedures. In the game, there's this document you find somewhere where it says that, so they were particularly interested in that specific sample that you see, even though the analysis revealed unexpected spectral analysis fluctuations within that sample. They chose to proceed anyway. We understand this is a violation of normal anomalous materials handling protocol, so I have already authorized the enclosed material requisition form. And I find that interesting when there's a policy exception because that doesn't prevent an incident. It's just a administrative function to say that, yeah, we knew about it and it supposedly absolves you of some responsibility, where you say like, well, you signed off on it. So now the person who signed off supposedly was accepting the risk of a bad thing happening, but the bad thing still happened. So even though there was a policy exception, there were insufficient compensating controls to really avoid any incident here, which means there was no extra guard rails or guidelines or controls for exception, right? They could have maybe tested at 100 or 90% instead of 105 or slowly increased. Then there was another issue of ignoring your logs or monitoring. And that is when they saw a discrepancy but chose to not do anything, no action taken. So maybe they should have shut down early. Then there was no shutdown redundancy. As in, if the first mechanism to shut down failed, then there could have been another one, maybe a button inside the sandbox itself to shut things down that could be pressed by Gordon, the agent. And then the final point is inadequate sandboxing, as in there was a container escape overall at the end, and that leaked to the entire facility. Now, how does this tie into what we're seeing happen with just AI in general, or developing software with AI? I want to talk a little bit about zero trust. So you may remember about 15 years ago-ish, people started talking about zero trust a bunch. And the idea was that back then you had your perimeter, which in this case is the Black Mesa Research Facility. And the idea was that that could have been like your office infrastructure, and anything that's coming from the office, I inherently trust it and I allow it to communicate with everything else inside that same boundary. And that was insufficient. We don't trust everything that's within our perimeter. I actually want to authenticate things based on their identity, regardless of where they're coming from, which is reasonable. And so we started shifting into more identity-based authorization. And so regardless if you're within the perimeter or not, then you have like your endpoint, which in this case was Sector C. Think about it as like maybe like your laptop that's SSO'd through Okta. Like the agent has authorization to be in there anyway. And then that's still not enough. And so now we're all talking about how do we sandbox our agents. So in this case, Lab C33-A is the sandbox, and that is the specific room where the experiment was conducted. These are use cases that we're starting to see with AI agents as well, in that people are starting to avoid running them on your laptop, especially when you want to run like an autonomous agent or give it context that you don't necessarily trust. And so you want to sandbox it. Now, what's running in the sandbox? So I have my context itself that's in the agent, and that's like the instructions, the prompts we were receiving from the scientists. Then we have the agent and its identity, which is here Gordon Freeman. And then you have a model ? Well, in a way, I consider the model to be generally outside of the sandbox. And that is because you could be running local models, but most of the time the models are hosted elsewhere. And for example, the models can be running on Anthropic's infrastructure. So in this case, this is hosted on the planet Zen, which is where the crystal is from, or Anthropic or OpenAI, or maybe Bedrock, AWS, or your own local instance to host the model. But that's generally, I consider to be external to the sandbox itself. Now, in between the agent and the context, I feel like we have tool calls, and that is the agent's just allowed to use tools that are available to it within the sandbox to interact with the context or add more data to its context, and then the agent interacts with the model as well. And that's, for example, making API calls to Anthropic, Claude, Opus. Now, one thing I want to touch on is what do we mean when we say agent here? So I want to have a small note here about agent types. Examples of agents are, you have your coding assistant. Claude Code is an example of an agent. And you have automation assistant. And this is a broad category, and you have like many different types of automation assistants you could be using. One example is a bug finder. Many people are using AI to find bugs today. That's the example of an agent. An investigation tool. You could have an agent investigating your logs, investigating other tools and behavior to flag things, doing like incident response maybe. Another example is an auto pen testing tool, and we're seeing a lot of like red team related agents being used very successfully. Then other than like things that can run on a specific machine traditionally, you have your CI or workflow automation agents, and that could be something running as a GitHub action within your CI/CD pipelines. And we're starting to see more of that, agents running within CI. Then more than that, there's also basically like in product agents, like a chatbot on a web app, or just any sort of automation in general. And so many products, people ship like SaaS or whatever, and those have agents built into the product itself that users can interface with. And so in those instances in general, I would like the architecture of the setup to be something similar, as in you're running things within a sandbox. Now, one of the challenges here is, how do you make sure that the agent's doing the right thing, right? How do you detect bad stuff happening? So traditionally on the endpoint, we had things like EDR that would run here. Like that's your like CrowdStrike, Sentinel-1. And well, initially you had antiviruses signature based, then it became slightly more focused on behavior, but that hasn't really been optimized for like agent behavior, especially not when you're running it isolated. And so some of the questions we ask ourselves is, can we do intention analysis? And the idea is that, how can I distinguish between an automated agent action that is doing what it's supposed to do with good intentions, or a malicious one that was either manipulated or making a mistake, which can happen? And in general, like, what is malware? Like, how do I know if something is malware? Can I broadly define a certain behavior to be malicious? Can I broadly define a certain binary to necessarily be malware? Not really, because then isn't every shell script malware? Isn't the curl command fetching a malicious binary also malware? What is bad intent in general? And that you can apply it to humans, because how do you know if a human is manipulating you or lying to you or trying to deceive you? Then you have issues like the halting problem or the Rice theorem. And the idea is that semantic properties of programs are undecidable, which means that we'll never really reach a phase where just by static analysis I can tell if something's good or bad or behaving as expected. But there's always good steps we can take to help in general. And so the first one, there's an idea that I really liked, is the idea of evaluating the reasoning of the agent. And I found that in this talk by Joshua Sachs, which was presented at Unprompted Con. Now, this recording was released 3 days ago. That it's a really cool talk. Your agent is generating some reasoning, right? And you can see that when you observe an agent working, it has basically its own log lines. You can see it in Claude Code sometimes. It's displaying the reasoning lines, like line by line. And so what if we run analysis on the reasoning itself? And so as an example here, I put it outside the sandbox, but I mean, should it be in the sandbox? I'm not sure. But the idea is I run log reasoning, which is kind of similar to having a sim or like in Splunk. And should it also analyze the context? I haven't really thought that through. Like, is it sufficient to just analyze the reasoning of the agent itself, or should you also be analyzing what's included in the context? It's probably a good idea to also analyze everything that's in the context itself. And what's in the context? I mean, that's everything from the prompts and the instructions that you're giving the agents to the code that they're writing or analyzing to the tools and the output of the tools that they're calling. Like essentially everything the agent's interacting with is part of the context. So reasoning and context analysis goes here in these arrows, and you could be doing that, like you can either be shipping it outside or doing it on a different system, or have like a separate agent doing that in real time. And the idea of evaluating the reasoning is a good way to help tune your agent, like is it doing the right thing? And then there's also an idea from another unprompted con talk. This one was from Rami McCarthy. He had the idea of injecting skepticism. And that seems like a fairly solid strategy that's successful in that you ask the agent like, hey, like, do we trust the prompt here? Do we trust the instructions in the context? Do we trust what we're seeing? Is this really the action we need to take? And getting it to doubt itself tends to help in many cases. Now, when you have all of this, that being said, I want to talk a bit about the details. So this is in theory, right? Like it's nice in theory to know that, you know, you have sandboxing, maybe you analyze some of the context, but in practice, what should you do? How should you achieve a hardened setup like this? So I'm gonna talk about sanitization or hardening. And the first thing that I'm interested in is the tools itself. So you can allow, list, or restrict the tools that are allowed. And so that could be the tool calls themselves that are available to the agent. Like what exact tools are they allowed to run? Not every agent should be running within the same sandbox with the same set of tools available to it. As similar to restricting capabilities in Kubernetes environments, you only give it the exact capabilities that are necessary for it to do its job properly. Like right now, many of us just run Cloud Code on our host, and everything that's installed on my host is available to Cloud Code. But why? Does it really need access to Brew, my package manager on macOS? The other interesting piece is the context itself. Now, within the context, you have also things like skills, MCP, config files like claw.markdown. What about those? Are those sanitized in any way? And that's also a good idea to add an extra step before injecting the context to analyze the context itself. And now it could be in the log and context reasoning step here where you do it. And then you're thinking of the sandbox itself. And so here there are a few options, like for example, Claude built in sandbox, or Docker in general. Any Docker container could be a start. Then you have things like Membrane. And so Membrane is this repo by an operator, Caleb Gross, a very smart guy. It has the right idea here of doing things like network egress filtering, file system isolation, observability, nested containers, and works on macOS and Linux via Docker. And this is the solution that you would want. Now, is this going to be permanently the best solution that everyone uses? Not necessarily. I mean, every day I see like one or two new GitHub repos saying like, hey, we're a agent sandboxing solution. Which one's going to be the best? I don't know. Maybe Claude Code is built in containerization, ends up being more advanced eventually. And that's going to be a theme with a lot of these concepts that we're talking about. Everyone is just trying their own solution right now. And maybe in like 6 months, we'll have like widely adopted solutions that everyone uses. But for now, it's kind of a mess. everyone's doing their own thing. And another idea I hear a lot these days is just using a VPS. We're kind of going back to the like using a terminal to the mainframe idea, but instead of running the agent locally, not even in Docker, I just set up a VPS, like a server on the cloud, and I SSH into it, and that's how I interact with the agent. And that creates isolation. Now, people have been saying they like that. I'm not sure if, just to me, that seems more tedious than just running Docker locally, but it's not necessarily a bad idea. Then I want to talk about dependency management. And before I get into that, there's a really good talk also at Unprompted conference released a few days ago by Dan Guido from Trail of Bits, and he basically goes through how Trail of Bits is doing some of these things. They have an open source repo where they have a bunch of like skills they build and some of the strategies they're taking here. And a nice thing he mentions is for the package manager, just set up a 7-day cooldown. And this is not specific to AI at all, but any dependencies that you use, and we know that like, Claude likes to just download random dependencies and try them. You can force it to only download dependencies or versions that are 7 days or older. Anything updated within the last 7 days, I don't necessarily trust, as we've seen from recent compromises, like Truvi from Aquasec. Because if anything's compromised, it takes a few days, at least for people to notice. So when you download and use an older package, there's more chance that if it was compromised, people would have noticed. So this is generally good practice. Then enforcement of the setup itself via mobile device management. And for example, Jamf, and he also mentions that at some point they're going to open source their Jamf configuration. And Jamf is a device management tool for macOS. So if you have a company where everyone is using macOS, use something like Jamf. And this is important because it's not just about your personal setup. If you work at a company, you want to harden the setup for like everyone at the company. How do you do that? So having a set of like basically approved configuration files and pushing that to everyone so everyone has a consistent setup is important. So now there's another problem of prompt injection, and that is still largely unsolved because of the problems of like intention analysis that we spoke about. Because prompting is just natural language, and natural language processing is hard even for humans. Like if you ever thought like, is this person being sarcastic or not? Is this person attacking me? So it's the same for agents. Like how can you sanitize a prompt to know if it's actually trying to manipulate your agent or not? Now there are some steps to help. So for example, if you are running in a very untrusted environment, in a very, very sensitive environment, you could just deny internet connectivity completely, as with normal setups outside of AI. And another neat thing to do is wrap the agent execution environment. For example, you have agent sh or no. These are sort of sandboxes. I've heard mixed feedback. Do they work properly? It's not really clear. They're all very new. People are still trying out things in this environment. No one has a solid solution for this yet. No one really knows with confidence, like, oh, here's the one thing you should do because this is changing very fast. And if I give you the name of a tool, next week someone might break it. And the week after, a new one comes out that everyone's using. So it's not really about the specific tool name itself, but more about the concept. And wrapping around an agent execution environment is basically something that determines of like, is this action supposed to run or not? It's a sort of runtime analysis with capabilities that are allowed, listed, denied. And that's similar to policy enforcement in general. Like, what is the agent allowed to access? So these all tie together, like the sandboxing idea and how you configure it, how you enforce the policies in it. And one of the core ideas for me here is just I don't trust any of these solutions that we see at all. Nothing. And so what Trail of Bits has done is you just curate your own library to include like tools, skills, MCP if you want, config files, and having your own curated library helps harden the setup a bit. And all of these steps overall, if you look at the big picture, we're basically saying move away from just running your agent and giving it permission on your host, especially if it's an autonomous agent, into more sandboxing and being very deliberate about the access. And that's why I remember zero trust, and I feel is very relevant here. And the same, like this is all an extension of what we've seen of zero trust. It's a continuation of the same initiative of we used to trust everything in the perimeter. Then it's like, okay, well, I need to break it down a little bit based on identity. Then it's like, well, what is an identity now? Because you have human identities, but then you have autonomous identities, and now today they're often running on the same machine. And so how can I distinguish if this action is being taken by the human or by the agent on that machine? There's a separation that needs to be done there. But then, does it even matter? Because I also have like Claude remote access today, which was C2 as a service. We used to call that remote access Trojan. And now it's just a feature that people want to use. And then you have OpenClaw. And so this is where some of the context analysis, reasoning analysis, and runtime analysis via a series of just enforcement of allow lists, constraining the access, curating what it's allowed to access. None of these have solid solutions yet. It's all a work in progress. We're seeing the general strategy and architecture of how things are starting to look and why and where things are heading. I think in around 6 months, we will have like brand name tools for everything on here. For now, it's kind of just a big experiment. And I just think we need some. I just think we need some.
Time, Dr. Freeman? Is it really that time again? It seems as if you only just arrived. You've done a great deal in a small time span. You've done so well, in fact, that I've received some interesting offers for your services. Ordinarily, I wouldn't contemplate them, but these are extraordinary times. Rather than offer you the illusion of free choice, I will take the liberty of choosing for you. If and when your time comes round again. I do apologize for what must seem to you an arbitrary imposition, Dr. Freeman. I trust it will all make sense to you in the course of... Well, I'm really not at liberty to say. In the meantime, this is where I get off.